Atomic Pudding, we are going to introduce how we came up with the idea of the modern day atom. We're going to go through some of the history of it, and we should understand the differences between the models. Specifically how we developed the Thomson model and the Rutherford model. We should be able to explain the results of Thomson and Rutherford's experiments, identify the models based on description, and put them in order of how they were developed. That's what chronological means, in order of time, from oldest to newest. And that will make more sense as we go on. So, moving forward, the first guy that really came up with the chemistry idea of the atom was Dalton in the early 1800s. And he came up with this idea that there was a tiniest piece of matter that you couldn't divide. So, copy this down. So, like we talked about before, so Dalton, he put together the idea that the atoms were like Legos, like individual pieces of Legos that couldn't be broken up. Now, that's the idea, and you can take them apart and rearrange them together. Now, he called elements pure substances because all of the atoms that were the same element, he thought they were the same size. That's essentially what he thought. Okay? So, get this down. So Dalton, to sum up his idea, is he had that every individual atom was a specific type of element. Okay? And he had said that all elements that were the same size were the same element, which is pretty much true to now. We're going to learn a little bit more about that later. So Dalton's model is a solid sphere that cannot be divided into any smaller pieces. That's a key idea here. That's the first model in the atom. I like to call it the pool ball atom, like the billiards. Like they're just solid spheres. All right. So let's come back to this in a sec. So all right. So Thomson's model here. Thomson came up with the cathode ray tube. And you guys may remember, you remember the big TVs with the big backs? The old style TV. Yeah. Some of the classrooms still have them in here. Listen up, guys. So those TVs had cathode rays in them. And the cathode ray is just a beam of electrons. So what Thomson did, Thomson found that if you put up like a barrier in between the cathode ray, in the end, it caused a shadow. He also found that if you put an electric plate, an electric field on this beam, it was attracted to the positive side of the electric field. So, if something's attracted to a positive charge, what is the charge of the thing? It's a negative charge because opposite charges attract. So that's where he came up with, Thomson came up with the idea of the electron. Just a negative charged part of the atom. That's what he came up with. Make sense? So, the big deal with Thomson's model, Thomson found the electron. He didn't know that there was a positive part, but you don't have to write that down. And he said it was like plum pudding. That's where they come up with this idea of atomic pudding. I like to call it the chocolate chip cookie model. So guys, envision a chocolate chip cookie. Like where the chocolate chips are the electrons and the cookie is the positive part. Right? He just thought that these negative little things were just inside the atom. So I like to call it the chocolate chip cookie model. Since Thomson was from England, he called it the plum pudding model. They call plums are like little currants or little raisins. And plum pudding was just like this gross snack that they ate back then that nobody liked. Yeah, the British people liked it. So he called it the plum pudding model. Okay? So Thomson proved, to sum this up, Thomson said that any element can emit these. So any element has electrons. All atoms had electrons. And he figured out that there was a positive part of the atom, but he didn't know much about the positive part. Does that make sense, guys? Good? Good. All right. There's a picture of Thomson right there. You know why people in old pictures all looked sad? Kareem.
They have no money.
Yep. That's great.
Exposure time.
Long exposure times, so they couldn't move. They had to sit perfectly still.
Well, you can't hold them. Smile.
Imagine trying to do a selfie like that.
Smile.
The same exact smile, your muscles will start your cheeks.
All right. Moving forward. We talked about plum pudding, blah blah blah. Rutherford. You guys really want to pay attention to this, because this may be on a quiz if Mr. Cops and I are making a quiz, which we are. He actually studied with Thomson. You don't have to write that down. He noticed these little alpha particles, don't worry about what those mean yet, but they're tiny, tiny particles, were deflected in air. And he came up with the gold foil experiment, which is one of the most brilliant experiments ever that scientists came up with. And also, very surprising experiment. He was very shocked by this, as was the world.
Are you literally thinking that he got shocked?
No.
Okay.
No.
The way you said it just made it seem like you got
He did get struck by lightning. No, I'm just kidding. Just kidding. He didn't. He may have, but I'm not going to. So he came. The big idea you want to talk about is the gold foil experiment. We're going to discuss that right now. Okay. So Rutherford's experiment. He had this little lead block with some uranium in it.
Oh, yeah.
Okay.
Absolutely right now.
He had some uranium, and uranium is an alpha particle emitter.
Some of us didn't get a chance to finish copying all this slide.
That's fine.
I'll go on YouTube and get it.
Yeah, I'll go back to it. What he did was he expected that the alpha particles would pass right through the gold foil because he thought the positive charge was spread out in the atom, like the cookie part. So what he thought was the alpha particles would go right through the gold foil, like a bullet would go right through a cookie. If you had a BB gun and shot a cookie through it, shot a cookie with it, the bullet would go through. That's the idea. What happened blew his mind. What happened was that some of them went through. Some of them were deflected. Some of them were deflected a lot. And some of them bounced back. Some of the alpha particles bounced back. And what he alluded this to was like if you shot a bullet at a piece of paper and the bullet bounced back. That's how crazy this was to the scientists at this time. So it was pretty crazy. So the real big idea about Rutherford's experiment was that there was a part of the atom which had most of the matter in it. Most of the mass of the atom was centralized inside this part. Anyone know what that part's called? Close. It's an N-word. Say it louder.
Nucleus.
The nucleus. Great.
Oh.
He came up with the idea of the nucleus. Boom. So Rutherford came up with a nuclear model. Moving forward.
Can I just take 1 point?
Oh, yeah. Mr. Kopp's going to make 1 point right now. Okay. So Rutherford came up with a nuclear model. Niels Bohr, you don't have to copy this down, but Niels Bohr, clearly crazy because of that picture. Look at him. Nuts. Another brilliant... He was a brilliant chemist and physicist, and he came up with the Bohr model, which the nucleus, which builds more on the nuclear model, where the nucleus was in the middle, but the electrons were in orbit around that. And I think you guys actually learned this in 8th grade physical science, where you had the first shell had 2, the second shell had 8, third shell had 8, blah 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 blah. So we're gonna take that a little further. So Niels Bohr came up with the what do they call it? The Orr-Planetary model of the atom. Okay. This is after Rutherford. But he said they travel in orbit, in a definite orbit, kind of like the planets go around the sun. So that's the Bohr model. So you guys should start to see how they're developing upon each other.
Do you guys see how these pictures have changed over time? Right, it's step by step. First we thought they were just little spheres, but this doesn't really tell you much about one.
So that's the planetary model of the atom. Now, Niels Bohr and Albert Einstein, two guys you've probably heard of before, because we just talked about Niels Bohr, and I know you guys have heard of Albert Einstein, came up with the quantum mechanical model of the atom, which we will talk about. So basically, this idea of the atom was that the electrons are in the electron cloud, and that's pretty much the current model of the atom now. And they're in these spaces called orbitals. So they're not in a definite orbit, but they're in an orbital where they're most likely located. And I'm going to give an analogy to this. My orbital, Mr. Kilgore's orbital, is B108 and C116. Does that mean I'm there all the time? No, because I do go other places. Like sometimes I go to the office. Sometimes I go make copies at the copy machine. Sometimes I go to the restroom. So I'm not definitely there all the time, but I'll probably be in one of those two places. So that's what they came up with the idea of the orbital. So that's our modern view. Most of the atom is empty space. We have the nucleus, which contains the protons and electrons, and the electron cloud. That's where the electrons are most likely located. So I'm going to let you guys copy this down.
Oh, I'm sorry, I didn't know you
Oh, so next slide. All the models of the atom are here. Dalton's model, the plum pudding model, and this is on the next slide. Bohr's model and this cloud model. So this is all the models right here. Can you guys see those? See how they kind of developed? Mr. Costa's drawings are better. And there's our objectives, and we're calling it a day.